Welcome to my channel. In this video I will try to fix this multimeter. It's a Beckman Industrial one. Its model is dm97. All the functions are okay except for the voltage. The millivolt is okay, ohm, the diode test, the frequency, the milliamp, the capacimeter. Only in this range I didn't get any reading. So if we can test here, for example, for the voltage, for the junction test, we have a reading. For the capacitor, for example, it's a bit slow, but it gives the right reading. So the millivolt also works. We can test here for the millivolt. We have 315 millivolt. So maybe the voltage divider or the input for the volt, the input stage has a problem. Now we will open the meter and we will see the inside. I didn't find a schematic or a user manual for this meter. It's an OLED one. We must remove the bezel. I pasted it with a tape. It has a metal threaded insert here. It was repaired before. I didn't remember if it's me or it's bought with this repair. We can open here the case. We have here a ceramic model. This model, maybe it has the input divider. We will check. We will remove the battery. You can see this flickering because I use top tape of projector. They are not. They haven't the same frequency. Maybe I will disable two of them. So here we have the input for the voltage. Here the common, it's connected to the ground. Here we have the input for the voltage. So we can find here this may be 1 ohm or 10 ohm. I will measure this one. Also we found this component. It moves a little bit. I will try to measure this resistor. 100 ohm, 99.7. We can found a position for a good reading. So this first resistor is connected directly to the input, to the voltage input. We have two resistors connected directly. This one, and this one. This one, it measures 100 ohm, and this one measures 1K. So it's okay. Brown, black, and red. So this is 1K resistor. We must see where those go. This one has a cover. It has a cover. Maybe this is a varistor, maybe. This one, it goes directly to the selector. Here we found the selector. And the other one, the 1K, goes here for this component. It said SPO2. It's like this one. It has the same shape. Maybe a varistor. It's split in half. Yes. This is the cover, the white cover. I will use my microscope to inspect this one. I did a research about this component, and it's a spark gap. It's used here to protect the PCB of the meter. If we apply high voltage here, there is a discharge inside this component to prevent the high voltage from damaging the circuit. Here we can find its role is like those gap made with the PCB here. We can here see the. I think that the spark will jump between those two poles here inside in this gap. It's a Japanese component. Here we can find the voltage. For example, this one, AG20, it said AG20. Discharge starting voltage at 200, maybe 1200 volt nominal value, or 1500 volt. They are okay because they are not shorted. If we test here with the continuity, we found that those gaps are not shorted here. We have this one and this one. So I will inject a voltage here and say see if we found something here. I will use this battery. It's 8 volt battery. You can see it, rechargeable 9 volt battery. We have 8.0. I will use the leads of the power supply. Here we have the common. And here we have the voltage input. I will put 9 volt here. We have the plus and the minus. And we will trace the voltage here in the PCB. We have here DC voltage. So we put the ground here. We have in the input we have 8 volt. It will be split in two. We have here a 100 ohm resistor. We have 8 volt and 1 k resistor, 1 kilo ohm resistor. This was 100 ohm resistor. If we follow the trace, it go to the selector. We have 8 volt here, and the other side we found 8 volt here. I found that this is a voltage divider. It's a ceramic module. We will see its data sheet in the download. Here is the module, the same one with the same reference. C34, 17C34. It's a voltage divider made with different resistor here. Maybe they are laser trimmed. We have the input voltage divided by 10 or 1 or 100 or 100 or 1000. So here we will see C34 here. This one. So we have the resistor here between 1 and 2 and 4 other resistor. I will see which resistor is connected to the ground. I will remove the input voltage. We come here. This is the ground. One I will try to select this is the off. I will try to select the voltage. The first one, look, is off, horizontal off, and the first one is the volt. I will try to, it must be connected to the ground, one from this one. This one. So this is the ground. So I will put the voltage and we will see if there is a voltage here. I will put the battery as the source voltage. So here we have the ground, here the plus. I will set to the DC voltage. So in the input we can use the spring here. So we have here 8 volt in the input. I will see here. So we have here 8 volt, and here we have 0 volt. Oh, 0.4 and this one. So maybe the problem with this divider. Maybe the input resistor is gone. We have here 8 volt, and here we have 0.4. I must see the data sheet here. So we have here the dimension between this pin 1, between pin 1 and pin 2 we have R1. Here we have R1, and here we have the other resistor. So maybe here if we can find the resistor. So we must find the C34. C34. This one. So R1 is 10 meg. Here R1 is 10 meg. And then we have 1 meg, 100k, 10k, and 1k. I will try to measure those resistors. I will remove the input. So here we have cancel. Here we must find 10 meg in this. Those R1. This one is R1. We must find 10 meg. We have 8.7. Maybe there is the input resistor. We can select here to off. Here we can find 10 meg, so it's okay. 10 meg. I will see the other resistor. They are connected with the ground. So here we have C34. Meg, 1 meg, 1k, 1 meg, it's R2, R2 to R5. So here we can find 34, this one, R2 to R5. So the 10 meg it's alone and the other are connected. We have 5 pin. So here we have the common. We must find here 1 meg. It's okay, 1 meg. We have here 1 meg and 100k. 100k. It's okay. Then 10k. It's okay. Then we have 1k. So it's okay. The ceramic module is okay. I will. It's used as a voltage divider, high precision voltage divider. So they input here the voltage, and here we have to select the range. I will put again the input voltage. Here we have 8 volt. I will select the voltage. Maybe I will put a battery here. Now without the battery we will test without the battery and with the battery. I will put the negative here. So here we have, I will switch to DC voltage. In the input we have 8 volt. In this one we have 0.4. And here others. Oh, we didn't get any voltage from this divider. The input is okay, 8 volt, and here in the other part of the resistor, the 10 meg resistor, we have 0.4. And here same thing. I will put the battery here and I will do a test again. So here I will bring the 9 volt battery. Here we are in the DC voltage. You see here we have 0 volt, the reading. Now I will try to measure the volt. Here we have, I will apply, we'll put the volt. Oh, now it's function. What is the problem? Maybe bad contact. Yes, it functions. Maybe we have a bad contact or solder joint. So it said 3. Maybe the problem is with the grid of the battery here, but the other we didn't have a good reading. Two 2.3. .7. I will use the power supply to see. So we have here the voltage input. I will power on the power supply. I will put 5 volt the power supply. Maybe the problem is with the selector. I must reverse the voltage. Nothing. Now it's okay. 5.6. We can adjust 10 volt, for example. Here we have 8.3. So here we have 10 volt, but here we have 3 volt. I will measure the battery. .9. we will apply the voltage. Two point 4 point. It's not stable. Now it's okay. So we have maybe we have a problem with the selector. When I apply a force here, we have the good reading. Here we can put 5 volt, for example. This about 5, so it's okay. So the problem is with the selector. Here we have 0 volt. When I push here, maybe selector or other part of the PCB. I will now apply a force here, for example. It's okay. There is a bad joint somewhere here. I will apply a force on the module on this one. It's okay, so maybe this module. Maybe here we have a bad joint, a bad connection. So you see, I have here the good reading. I will inspect. I will inspect this module. Maybe we have a bad joint here in this one, this resistor. I will use the microscope. Here we found the problem in this junction here, in this connection. Because when I tried to measure here, I found 10 meg, the first resistor here in the divider. I found the 10 meg. But in the other side, I didn't find the same value. So here we have a bad joint here in this module, in this side of the 10 meg. I will resolder this part and I will do a test again. I will solder now the divider module. I will apply solder only on this 10 meg resistor here. I will try to apply the solder here. Here. I will try to apply solder from the PCB side and then from the other side. Here we have, okay. I found that the leg is no longer, we have a leg but it's tiny one. We can find here. So we will try to apply solder from the component side on this one. And we try to apply solder here. near the charge gap. I will try to measure the 10 meg here. We must find 10 meg between these two. Now it's okay. No, we haven't 10 meg. We still have a bad contact. We have 4 meg. I will try to measure from this side. 4.7. And now we have 10 meg. Now we have 10 meg. Because if we select the voltage, the input side of the meter, we will false the reading. We have 5.8 meg here, and when we select off here, we found the 10 meg resistor. After resoldering the divider module, it's okay now. We can do a test. We have here the 2 meters in parallel. We can see here we have a good reading, 8.64. Now when we apply a physical force here, we didn't have the same issue. We can vary the voltage. We have up almost the same reading. Here we can get a better view for the Fluke multimeter. It has auto ranging here. I assembled the meter. Now I will do a test again. Here we have the DC volt. We have 8.06, so it's okay. I will try to switch to the AC voltage and measure the main. And I will put on. It's okay. We have 238.3 volt. I will try to compare it with the flick meter. I will use another socket. We have almost the same reading. Here we have the millivolt range. It's okay for the millivolt. I can lower the voltage here to 300. The maximum voltage here is 400 millivolt for this range. I will test now. 300 is okay. 322 millivolt. For the ohm range, we have some resistor here, 1.5 kilo ohm. It's okay, 1.4. I will test it with the 50 mega ohm. It's difficult to measure this resistor This is a 50 mega ohm resistor. I will test. Maybe it can measure it. Overload. We can put two together to get the 25 mega ohm. Maybe it will give me some result. Okay, 25 mega ohm. Okay. Here we have 1 meg and 1 k. This is the 1 k, and this one the 1 meg. I can switch to the component. Here we can test the diode. It's okay. Here we have the frequency measuring. Here the microamp. For the microamp we can use the 1 meg here resistor. This one I will measure it. The color are so tiny. We can here do a test. Here we have 1k, so this one 1 meg. I will put here a 10 volt over 1 meg. It will give us 10 microamp. 10 volt. We have here. We must switch here to the microamp input. Here we have the positive. We have 10 microamp, so it's okay within the spec. For the milliamp, we must use the 1k. Switch to the 1k, and with 10 volt. With 10 volt, we will find 10 milliamp, so it's okay. For the amp reading, we can use the same thing with this 1k. We have 10 milliamp. The capacitor, it's okay. I tested the capacitor. It's good to find the meter with this input, dedicated input for the capacitor. We have 4.7 nanofarad. It has a hold, the min max, the max and the min. So now we come to the end of this video. Thanks for watching, and have a nice day.